So sound versus light waves, okay? There was several different things you could have mentioned. I only asked for one. If we look at sound and light, if you change the amplitude, the sound, the volume will change, or the brightness of a light will change. Okay, that's one option. Another option is if you change the frequency of these things, then the sound, the pitch will change, and the light, the color will change as well. Okay. Caleb and Robert, make sure you get your warm up here. Alyssa, can you see the TV okay? Caleb, can you see the TV okay? Okay, good. Okay. Another thing which some of your classmates mentioned is this medium versus no medium. So mechanical wave, sound is an example of a mechanical wave. Light is an example of an electromagnetic wave. Now sounds require a medium, okay? Light does not. So some major differences going on here, okay? Questions on any of this? All right. So what we're going to do now is we are going to go through that formative. So what I want you to do is go ahead and reopen your formative. Let me take a look at what you guys did. I don't want this. Period 3. Okay. And I'm looking, and some of you got, whew, some of you didn't do a single question. Woo-wee, you have a lot of work to do. Some of you got halfway. Some of you did the whole thing. Okay. So this is what we're going to do. We are going to go through the answers one at a time. Now, I'm going to warn you, this is pretty boring. Okay. So you need to turn off any distractions at home, put away, keep yourself awake and alert. Tell me if I'm going too fast. Ask questions if you have it. I highly encourage you, as you're going through this, let's say you didn't do any of it, start doing it now as we're going through it. I've already recorded the answer key quickly, like I scrolled through the answers for you, and that's already posted on Google Classroom, okay? Along with these slides. There's only a few slides. But what we're gonna do together right now is go through them one by one. What you really wanna do is make note of which ones you got incorrect, because what you wanna do is use this information to prepare for the exam. Remember, you cannot access the formative during the exam. However, you could have the information from the formative in your notes, okay? So whether that's a screenshot or a copy and paste, or you're writing it pencil paper, you may use your notes on the exam. You do not have access to this formative during the exam though, okay? All right, here we go. So, oops, let me go to number 1. Okay. So I have my answer key here now. And what I'm going to do is just take my time. I'm going to go through each of these questions one at a time. Let me know if I'm going too fast. And please let me know if you have any questions. I'm going to change the chat box to everyone can see it now. And let's look at number 1 together. Again, if you didn't do this, you're doing this now. So I have several of you. 1, 2, 3. I have 3 of you that did not do number 1. So get on there now. The given values. They gave you velocity and distance. The unknown was time. The equation is distance over velocity. And then when we substitute this in, you're going to end up dividing 75 is on top. So you divide 70 by 15, and you're going to end up getting 5 seconds for that one there. Okay. 5 seconds. Okay. All right, Izzy, so make sure you are on number 1. Good. Everybody else, I can see you writing on it now. Okay. Well, they gave you the velocity. Now, remember that velocity and speed are the exact same thing, okay? The only difference is that velocity has direction with it. So they actually gave us, we have the boat's velocity. You have to assume, since they didn't give us direction, that it's just going forward. But for this problem, the direction isn't needed. It's not necessary, okay? If we take distance divided by the speed or divided by the velocity, remember speed and velocity are the same thing, you can determine the time it took to travel. Okay. Other questions? We're good. I got a thumbs up. Okay. Stay awake. That's your job. Yes.
Well, back to what you said about the notes, so you're saying you could just take a screenshot of the problem.
Yep. Yep. If you have your digital notebook and you just want to take a screenshot of something, you can just put that in your notes and then you're good to go. Okay. Number one. Oh, he put the answer. Thank you, Sahil. Okay. Number two. Now we're trying to find the distance. So they gave us the time. They gave us the speed. We're looking for the distance. So the distance is speed times time. So when I substitute this in, I end up getting 10 kilometers for this one here. Okay. State test, you wouldn't be able to use any notes. So I guess this is better. Okay. So Angel, Bailey, Drew, Faith, Izzy. This is number 2. Keep up with us. Okay. Now, on the final exam, you won't be required to give us the guess method. Okay. That's not required, but it's encouraged because following the guess method helps ensure that you do it correctly. Okay. So it's not required, but definitely encouraged. The guess method. Okay. Izzy, are you with us? Izzy, last chance. I'm gonna mark you absent, lady. Are you here, Izzy? All right, I'm gonna mark you absent. All right. Here we go. Number 3 is a little confusing on here. Okay. You have to ignore this part. I wish Mr. Trombetti didn't put that in there. Okay, or at least this question. Because what you're trying to do for number 3 is use the information from the previous example. So this is the information. If you took a bike ride, blah, 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 blah. But we're not trying to find how far you went. I wish he would actually, I could do that now. Huh. Can I? Sorry, let me fix that. Number 3. No, because he did an image. All right, live and learn. So, nope. Yes. When we're talking about velocity, remember I told you velocity is the same thing, and ignore this response, that's not correct. The correct answer is going to be your speed and direction. Velocity and speed are the exact same thing, but it has direction. They told us it was going south. You're not going to use any other information except for the speed that they gave you. They gave you the speed, which is 4 kilometers per hour going south here. So I wish this didn't look so confusing on the screen. Okay. All right, I have several people writing. I have people online. Good. Bailey, this is number 3. Stay with us, girl. Rihan, this is number 3. Izzy, if you ever join us, that's number 3. Okay. Okay, number 4. Let me know if I'm going too fast for you, okay? Forces that are acting on an object that continue to remain at rest are balanced. Remember Newton's first law, which happens to be the next question. An object in motion or at rest will remain that way unless there's an unbalanced force acting on it. So if it's going to remain at rest, it's not going to change its motion, then the forces are balanced. They're going to stay balanced. Okay. Good. I have you all with me. Good job. Number 5. Again, Newton's first law. An object at rest or in motion will remain at rest or in motion unless an unbalanced force acts on it. Yeah. Good. You do not have to have it word for word like mine, but you do have to mention it being at rest or in motion, that it'll stay that way unless you have that unbalanced force acting on it. So it doesn't have to be word for word. So he'll give you a different example, which works fine. Unbalanced force. Okay. You want to expand more. The law of inertia is good, but now explain what inertia means. Remember, inertia is to resist a change in motion. So if you're already moving, you want to stay moving. If you're already at rest, you want to stay at rest. So you need that unbalanced force to change that. So expand more. Okay, number 6, second law. This is one way to write it. There's several different ways you can write it. So the force of an object is equal to the product of its acceleration and mass. Now, I believe in our notes, we said the acceleration of an object is dependent on its net force and mass. That works too. But you have to mention force, acceleration, and mass. Okay. Yep, I need to slow down. And if you missed, you can scroll up in the chat. Thank you, Sahil, for putting the answers in there as well. But I was asked to slow down. I will slow down definitely. In fact, while you're catching up, oh no, I'd have to change my view. Oh.
Ms. King, is it backwards? Isn't it the acceleration of an object depends on the force and the mass?
So they both are correct. If I have an object in motion already and I know its mass, I can calculate how much force it's going to have when it crashes into something. I could also determine the acceleration of an object if I know how much force is going to be applied and the mass of the object. So they're both correct. Those 3 things are related. So you can calculate different things knowing force, acceleration, and mass. Okay? Are we good? Okay. Last one, and then I want to do my Newton's cradle with you real quick. So, third law. Every actionary force has an equal and opposite reactionary force. Okay. And I brought out my Newton's cradle. And I got the camera set up pretty good. So I'm going to change views. I'll wait for Sahil to get that up there. Okay. Third law, every actionary force has an equal and opposite reactionary force. Okay. So let's review Newton's laws one more time. It's been a long time using Newton's cradle. Okay. And I have it here. Okay. So remember this thing? Okay. I'm wearing black, which is kind of nice. There we go. Okay. So Newton's first law. Objects at rest will remain at rest. So these are at rest. They're going to remain at rest unless I add an unbalanced force to it. Okay. Now these objects will remain, they're in motion, and they will remain in motion unless an unbalanced force acts on them. Now they're slowing down. According to Newton, they should go on forever. So there must be some kind of force slowing them down. Okay. We know that there's friction up here with the strings against the bar. There's also energy being lost when they crash into each other. So that's where the unbalanced force comes into play. Newton's second law. Acceleration of an object depends on the net force applied and its mass. So if I do a little bit of force, I'm going to have a little bit of acceleration. Whereas if I have a lot of force, I'm going to have a lot of acceleration. So it depends on that one there. That's a pretty good string. Good job. Then we have equal and opposite action-reaction. So if I pull 2 out, how many do we expect to come out the other side? Out loud, 2. Remember that? If we pull 3 out, how many do you expect to come out? 3. Right? When we have 4, how many do we expect to come out? Good. Should be 4. Whoa, what? And so remember doing these different experiments. I think we even did 1 on each side. Right? And we even did like 2 on one side, 1 on the other. This one's fun, but it's challenging. Oh, dang, I did it. And so we have the different equal and opposite reactions there. Okay? Questions for me? Is that also an example of waves? A disturbance in the medium. I suppose so. We could stretch it, but waves, not necessarily. Not necessarily. It's not a very good example. Okay, this is what we're gonna do. We're gonna take our first break. You have to get up. You have to stretch because I know review days are boring. So get up. Let's take our 3-minute break, and then when we get back, we'll get a little bit further. Come on back. We have gone through 1 through 7. We got this. We're going to pick up the pace a little bit. Welcome back. Let me know that you are back. Thank you, Marcus. Let's look at now number 8. I know this beginning stuff is a little bit more challenging. An example of waves. You guys think about it. I need to move forward. I'm sure we could apply it somehow. Oh, well, we need to move on. Okay. So number 8, they gave us this graph. They want us to find the speed. Okay. Speed is distance over time. They told us in 8 seconds. So if we go to 8 seconds, we have to use the graph to give us our distance. Okay. So if I follow the 8 up, I hit the line with this diagonal line, it hits right at 32 meters. So I have my distance, I have my time, I'm looking for speed this time. Distance divided by time, or 32 divided by 8 is 4. The units are meters per second for this one here, okay? So number 8, Angel, Bailey, good. Randy, make sure you get on there. Rihan, number 8, okay? Some students were wondering, how did I get this information? Where did I find 32 meters in 8 seconds last period? They gave me the 8 seconds. I had to use the graph to go up to the line of the object to give me my distance that they went. Okay, so I'm using the graph to get all the information. Questions on this? All right, Rihan, make sure you're with us. Here we go. Gravity. Gravity is an attractive force that brings anything with mass towards another object with mass. You could say gravity is an attractive force that brings objects together. That's fine. That brings objects together. I think I'm going to change my answer. There you go. Alexa Hill's answer. A force attracting all objects with mass together. That's the only requirement, is that you have mass. Here on our planet, everything has mass. Okay. All right. Rihan, make sure you're keeping up with us. Drew, this is number 9. Rihan, I hope you're there. All right. The inner planets. Let me go down a little bit. So I think there was a couple more that we came up with, but the inner planets, they're smaller, they're warmer, they're closer to the sun, right? They're closer together, less moons, no rings, rocky surface, more light, shorter orbits. Now, just like your astronomy exam, you're gonna click these on the final, okay? So you're gonna click these ones on the final. Okay. Now, when it comes to the outer planets, they're just the opposite. Okay. Pretty cool how that works out. The outer planets are larger, cooler, further apart. They have many moons, rings, are gaseous, less light, longer orbits. Now these older units are taking us, I'm going a little bit slower. When we get closer to the more recent units, things go a little bit faster. So bear with me. I warned you, today is not very exciting. Okay. Good. Faith, make sure this is number 11. All right. Thank you. And it's in the chat box as well. So number 12. I wish these were in the other order, but rotation is going to cause days and revolution causes years. Okay. So it's a little confusing how this is set up, but years are caused by the Earth's revolution, while days are caused by the Earth's rotation. Okay. So all you have to do on the formative is click and drag so that they pair up together. Click and drag. Okay. I see some of you have it incorrect, so make sure you flip them around, click and drag. There we go. Rotation days, revolution years. The force of gravity. Some students put gravitational pull. That's good. Pulls gas and dust together to form stars, solar systems, and galaxies. Number 14, an AU measures distance inside our solar system, and a light year measures distance outside our solar system. Again, all you have to do is click and move things around, make sure they pair up correctly. AU, this is number 14, inside our solar system, light year outside our solar system. Okay. Tell me if I'm going too fast. Drew, this is number 14. You guys are keeping up. I like it. All right. So my explanation is a little lengthy because I am your teacher. If yours is shorter, that's okay. So the Earth has seasons because it is tilted 23.5 degrees. If you don't have those degrees, that's okay. But what this causes is half the Earth now is getting direct sunlight for part of the year, while the other half is not. So if you're getting direct sunlight, it's summer for you. And if you're not getting direct sunlight, it's winter. Okay. Okay. So he'll put it a different way. Still correct. Questions on this one? Are you guys awake? Sort of. Stay awake. We're almost there. Number 16. Drawing a lunar eclipse. So I should have used a different color. I apologize. Here's my sun. Here's my, that's an E. It's a little sloppy. That's my Earth. And then this little gray thing is my moon. Okay. So in order for the shadow of Earth to fall on the moon, which is a lunar eclipse, it has to be in this full moon position. The sun has to be behind Earth. The moon has to be in front. Full moon position to see that shadow fall on the moon. Okay. Good. Number 16. Bailey, Faith. Number 16. Okay. Full moon. Good try. Put full moon in there, Sahil. Full moon phase. Number 17, the law of superposition. Now we're getting into geological history. we are going to pick up the pace a little bit more. So the law of superposition, the layers at the bottom are older, the layers on the top are younger. Remember my clay. We had layer after layer after layer. We had storms and winds and rains and floods and drought over and over and over and over again. And I want to show you a picture. We went to Palos Verdes this weekend, Abalone Cave, and they have these cliffs right off the beach. And where did it go? Here we go. And so I was really excited to take some pictures for you. I'm going to hold this up to the camera. Okay. So these were the cliffs right behind the beach, and notice all the layers. So, okay, I have another one. Here we go. This was in this humongous cliff right behind us on the beach. And me being who I am, I was so excited, and I wanted to show my 6-year-old, look how cool all these layers are. Oh my gosh. Each of these layers took hundreds of thousands of years to create. That's how old this hill is. And I was the only one excited about it. So the law of superposition, the layers on the bottom are older, the layers on the top are younger. Okay. Then we have here, what creates an actual index fossil? Why did that switch? An index fossil, it must be widespread. It's found in only one layer and is easily recognizable. So you just have to click these. Some of you, there you go, fix your clicks. Some of you need to fix your clicks there. Good. Angelica, this is number 18. And then Faith, number 18. Some of you have it, need to fix the clicks there. Okay, thank you, Sahil. Number 19. We have here the extrusion. The extrusion forms its own layer on the very top. The inclusion are little pieces of rocks. Older rock found in younger rock. An unconformity is where much older rock is touching much younger rock. Insert image. And then the intrusion is where hot magma cuts through layers, but it doesn't form its own layer. It doesn't reach the top to make its own layer. Okay. I'm going to give you a moment because I know this is a lot of work on the formative. Come on, Sahil, you're not going to try? Just kidding. That's too hard. The next question is having you figure out the order of the layers. And it's going to tell you also, assume that the intrusion is as old as possible. I'll give you a moment. I see a lot of you still working. All right, Rihan, this is number 19. At least try a little bit of it. All right, we're going to use the law of superposition to help us figure out the order of these layers. Just like I saw at the beach on Saturday, the layers at the bottom are older, the layers at the top are younger, unless you have these different exceptions. So let's take a look. So G and J had to be there first in order for B to cut through them, okay? So it's gonna go G, J, B. Those are your three most oldest layers. G, J, B. G and J had to be there first in order for B to cut through them. Okay. Then we have, let me screw it in some more. Can I make this, did I make that worse? Okay. So G, J, B were first. Then we just go up the ladder. C, I, E, H, F, but now it gets tricky because now we have this extrusion. Now you cannot have an extrusion unless it reaches the surface and can create its own layer. That means that when A cut through, D wasn't there yet. Okay. So A would have came, F was there, A cuts all the way through, forms its own layer, and then D piles up on top. So, yep. So the proper order, thank you, Sahil, is G, J, B. Get the click and drag all these letters. It's kind of annoying. C, I, E, H, F. Then A comes along, and then D would be your last, kind of like a cherry on top. Okay. Questions on this one? Okay, and so he'll put this in the chat box for you already. This is just what we just said right now. Those letters there. Okay. Questions for me? All right, let's get a couple more in before our final break. Plate tectonics is where the plates of our planets actually move, right? Remember we called the plates lithospheres. The lithosphere, or the plates of our planet, can move because there is molten magma lava right underneath in the asthenosphere. So the motion of the plates of our planet, due to the convection currents, remember they move in this circular motion in the asthenosphere, causing these plates to move. That is plate tectonics. Rihan, stay with us. You're falling behind. All right. Thank you, Sahib. Short version. All right. Next one. What is seafloor spreading? Well, this is when we actually have new seafloor being created because those convection currents, the hot magma of the asthenosphere, is moving outward, pushing the lithosphere, the plates, away from each other. It's a divergent boundary, exposing the magma underneath. And when it hits the water, it cools off and creates new oceanic floor, a new oceanic plate. Okay. Sahil said, when the tectonic plates spread apart, new magma comes out, creating more seafloor. Yep. That's good. Okay. All right, let's do one more, and then we will take our final break. Okay. So this was number 22. Drew, Izzy, I'm not sure if you're there. All right, last one. Actually, this is a good stopping point because the next one is about evolution. Okay. So get up, stretch, get a snack. 3 minutes. Let's go. We are a little bit over halfway. Now we're going to pick up the pace. It's going to get a little bit easier because we've seen some of the steps. Thank you, Marcus. Thank you, Derek, for letting me know you're back. Number 23. Now we're looking at comparative anatomy, and they want to know, how is comparative anatomy evidence of evolution? Well, remember, this is when we did the elephant versus the rat, and you guys colored in the bones. So if two different species have similar organs and or bones, it indicates they share a common ancestor. Okay. So comparative anatomy is looking at bones or organs to see if there's any similarities. If they do, that indicates a common ancestor. Okay. Number 24. How does fossil record support evidence for evolution? Well, remember the definition of evolution. Evolution is that we see a change in traits from generation to generation. If in fossils, if we were looking at fossils from layer after layer, the law of superposition from generation to generation, and if they show changes in physical traits, this is literally the definition of evolution. Okay. Number 25, embryological development. Remember, we looked at embryos and they all look so similar. They looked exactly the same in the beginning of their development. So when we have the actual development, they look so much alike that tells us they must be related somehow. Okay? So all embryos we saw have a tail, they have gills, and they have eyes. This tells us they must share a common ancestor. Okay. Number 26. DNA. Remember, we looked at like DNA of a banana versus the DNA of the person sitting next to you. And so the more DNA different species have in common or share, the closer their common ancestor is. You share like 60% of your DNA with a banana. You share 99.9% with the next human being. The more DNA you share, the closer related you are. The person next to you is not a banana, but you share 99.9% of the same DNA with that person. Okay. I'm getting you, I'm expanding your vocabulary. Indistinguishable. Say that 10 times fast. What is a common ancestor? Well, it's an early type of organism that two or more other organisms descended from. Oh, you just copied and pasted. You cheated. Cheater. That's right, the fly. So common ancestor. Remember we talked about you and your cousins. You share that common ancestor. Those are your grandparents. Okay? You descended from them. All right, 28. What's an adaptation? Ooh, we're getting to genetics. We're getting closer. Adaptation is that favorable trait that's going to help an organism survive long enough to reproduce. Okay, to reproduce. I think, Sahil, that's 27. And it doesn't have to be an animal. We could be talking about plants or bacteria. So you want to say organism for a common ancestor. Okay. All right. But an adaptation is number 28. It helps. This is any trait that's going to help you live long enough to reproduce. Okay. Number 29. What does it mean to be fit? You had to click, right? There's only two things on there that you needed to click. It produces lots of offspring and it can live for a long period of time. So the longer your lifespan and the more babies you have, the more fit you are in biology terms. Okay. Not necessarily. How strong you are, depending on the organism, isn't going to ensure that you have a lot of babies and live a long time. So strength, literally your strength, doesn't necessarily, it could, right? If you're a rhino, you want to be strong. But if you are a fern plant, that's not really necessary. Okay. Number 30. This one was a little bit applying. Remember, when it comes to asexual reproduction, you're just making clones or copies of the parents. So there's not going to be any variety of traits in the offspring. That means in asexual reproduction, you're either going to survive or not, the whole population. That's the risk of asexual reproduction. There's no variety of traits. If the environment changes on you, you can all die. Bye, see you later. But if you have a variety of traits, then some of you will be able to survive in a change of environment. Okay. All right, I think I'm going a little bit too fast. There we go. Number 30. 31. We had to fill in this Punnett square. The Punnett square, again, you just put in the actual letters. So these two left sides should be a capital A and a lowercase a. And these two columns on the right side should be lowercase a and lowercase a. Oh, dang. He's trying to make a Punnett square. Hey, that's pretty good. Okay. You see, you guys can't really see what creating a Punnett square. The next question, they want to know what's the phenotype of this first box. Remember, phenotype means physical traits. So when we look at the phenotype of this first box, capital A was long hair, lowercase a was short hair. So since this has the dominant trait, it's going to have long hair. That's the phenotype. Phenotype, physical traits. Number 33, what's the genotype? Well, those are those letters you put in there. Those are the genes. The alleles are these letters. So it's capital A, lowercase a for number 33. All right, Randy, Rehan, let's get on number 33. Drew, Angel, make sure you're keeping up. All right. Number 34, examples of inherited traits. I just put a few: eye color, hair color, lip shape. Could be anything, nose shape, hands. My niece and I have the same hands. It's really weird. Height. My great niece has a wonky toe. Like one of her toes goes like really weird. So that's from the other side of the family. That's not us. Okay. So wonky toes could be inherited. Okay. What's acquired? Could be you got your ears pierced. Maybe you dyed your hair. Maybe you got some tattoos. Ooh, hair volume. Could be hair type. Some people have thin hair. Some people have thick hair, curly hair. Yeah, hair type could definitely be inherited. Yep. Is knowledge an acquired trait? Some would argue yes and no. Okay, some would argue that could be a inherited, but definitely you can get the brains from your parents and then not do anything with it. So that it could be acquired as well. Okay. Yeah. All right. Mohawks could be acquired. All right. All right, transcription. You had to click and drag this so that it actually matches. Transcription is when the gene is copied. Translation is when messenger RNA is decoded. Okay. We're almost there. We have 4 more minutes. Ooh, good. I'm seeing it bubble up. Make sure you connect transcription with it got copied. And then translation, it got decoded. Good. Number 37. This was our warm-up. Mechanical waves require a medium. Electromagnetic waves do not. Yeah. Good. I like seeing it all populate. Boop. That's cool. Okay. All right. Number 38. Again, this was part of our warm-up too. Amplitude is going to change the volume of a sound, brightness of a light. Frequency is pitch for a sound. Come on, Sahil. And color for a light. Don't poop out on us now, Sahil. Although this is wave stuff, they should know this stuff fairly well by now, unless you're not paying attention. Okay. So Angel, Kayla, make sure you get this table in. All right. 39. This is going to take a little bit if you haven't done it at all. So remember, a transverse wave is when you have the up and down wave going on. Okay. I'm going to fast forward, pause. I'm going to come back to this one. Because number 40, you're drawing the longitudinal wave. This was hard to draw, but this is the wave that goes side to side. It's not up and down, but side to side. So I tried to draw some areas where it's smushed together and areas that it's spread out. Notice I'm not asking you to label the parts for this wave. So it's just the side to side. But number 39 is the transverse wave. We have the crest on the top, the trough on the bottom. The node is this resting point right here in the center. I wanted to pick a different spot for wavelength, so I just randomly picked this spot, and for it to do a complete cycle ends way over here. That's one full wavelength. I wanted to show you the amplitude different. Amplitude is half of the height, so I can go from trough to the node, or I could also go from the crest to the node. Okay. questions for this? 47. It's already 40. No, I have one more minute. Okay, so your job from here on out, this is due Wednesday night. I want you to use this to study, update your notes. So do what do I do now? Well, update your notes, turn in any missing or late work, study, explore. In these slides, I have links to the open house presentation that you can go through and review different parts of the year. And this review worksheet is due Wednesday by 8 o'clock. Okay. All right. If you don't have any questions, then I will see you guys on Thursday. I'll see you guys Wednesday. Homeroom check-in. Have a good day, you guys.